Welcome back, everybody. I'm here to talk to you today about application programming interfaces, or APIs. So we're going to begin just by talking about what is an application programming interface. Well, this has become one of the core tools in the computational social scientist toolkit who wants to study digital trace data. The types of data we've been talking about in previous videos that describe large-scale human behavior, often in digitized form. We're going to work through some examples today of collecting data through social media sites, but APIs could also be useful for collecting data from a lot of other places, and as we'll see, APIs increasingly can even analyze your data for you. So broadly, what is an API and where did it come from? Well, to answer that question, we're going to have to do a little bit of history of the internet. Years ago, in what us older folks like to call the Wild Wild West, most websites were kind of their own domain, their own kingdom. They had their own data, and if you wanted that data, you'd go to the website and get the data. Now, increasingly, with the advent of what became known as Web 2.0, the internet became massively interdependent, even more so than it was at the beginning. Why? Well, imagine a site like Facebook and wanting to, say, help its users share songs on Spotify, or maybe share a New York Times article. If the New York Times and Facebook's websites didn't have an efficient way of talking to each other and allowing individual users to share information with each other, well, Facebook's user base would suffer, especially if, say, Twitter was doing that. And the New York Times would surely suffer too, because it wouldn't pull in new audiences to its work, right? And so broadly, there was a moment in the history of the internet when everything became massively interdependent, and there was a real need for a new kind of technology to facilitate requests and delivery of data, and often large amounts of data, between one person or one organization and another organization. Now, the tricky thing is that this isn't as simple as just visiting a website and downloading all the data. Instead, APIs are technologies that allow certain types of people to collect certain types of data. So we're going to soon work through some examples with social media data, and Facebook's API might allow me to collect a small amount of information about me and other people in my network, but it wouldn't allow me to collect information from people that I do not know. And that's because of something called credentialing that we're about to learn about in just a second. But first, let's pull back and talk about the real opportunity here. Over the past 10, 15 years, we've seen just an absolute explosion of application programming interfaces. By last count, there are about 22,000 APIs out there today. Now, a lot of those are non-public. They exist within a company or maybe between two companies to share information, but well over 1,700 of them are now public. An API might be used to find information about a geographic entity from Google, or an API might be used to extract user comments about an article from the New York Times, and so on and so forth. And I'm going to give you a long list of examples that might be of interest to computational social scientists at the end of this video. But the main take-home story here is that APIs are exploding, and there's kind of a gold rush. If you can entrepreneurially identify a new API, that might well be an interesting new source of data that's not yet tapped by social scientists. So if you want to check out just broadly what's out there, you might check out Programmable Web, which is a website that creates an archive of all APIs on the internet at the moment, and also Any API, which is a site that tracks publicly available APIs. And there you'll find a lot of the APIs I've already mentioned: Spotify, Twitter, Instagram, even though you can't get much data from Instagram, and many, many others. So take a minute, click on those links, and see what you think. The next thing I need to teach you about is how an API works. Now, broadly, what we're doing every time we make an API call, which is the way that we as people who use an API make custom requests for data from that API, what we're doing is actually stitching together a long URL that has information in it about what we want to request and who we are. We then effectively put it into a web browser and then scrape the information that's delivered into the web browser by the API itself. Now, we're not actually going to do that in most of the examples we work through today, but I just wanted you to kind of broadly have some sense of how an API is working in case you ever have to start working with one that's not already well documented. So let's take a look at the Google Maps API. Here's the anatomy of a relatively simple API call. First, you'll notice at the beginning of this URL, there's maps.googleapis.com. And that's what you might call the base API URL. That's the URL that we're always going to put at the beginning of any API request. Next, there's a section where we're requesting certain information from a part of that API. Which type of variables do you want to collect? Sometimes these are called endpoints in API speak. One of the most challenging parts of learning to work with APIs is learning not only to learn about jargon specific to software development, but different types of jargon for different types of APIs. Next, we're going to specify the type of data format we want. In this case, we're going to ask for JSON data. And then finally, we're going to make a query. Here, what we're using is Google's geocode tool. And what that does is read in a piece of text, and then it returns everything that Google knows about it in terms of its geography. And I'll show you what that looks like in just a minute. Finally, the last thing and really important thing about our API call is that it ends with something called an API key. Now, a key is sometimes called a credential or a token. Basically, what it means is a secret code, and sometimes there's more than one code that you have to stitch together into one long URL. It identifies you as an individual to the API that you're trying to work with. This long code has information about what data you're allowed to access and how often you're allowed to access it. So when we put this all together, and if you had your own API, this one won't work because this is a fake API credential or key that I've put at the end of this URL. But if we were to use a real one and we were to plug it into our web browser, we'd see something like this. Basically, what you're seeing is JSON data. That's data that contains everything that Google knows about the search query. In this case, we conveniently search for the name of my university, Duke. And you'll see that if we kind of zoom in on this JSON data, and if you've never seen JSON data, don't be intimidated. Basically, JSON data is an efficient way of delivering large amounts of data that may have different lengths. So if we have variables or parts of a data set that might be long for one person, say number of tweets, but short for another person who maybe doesn't tweet that much, JSON is just an efficient data storage format for moving that data around all over the internet. Okay, so we get stuff like the latitude, longitude of Duke University, we get the state that it's in, and we get various other kinds of geographic information. You may want to use this type of geocode tool for all sorts of purposes if you do work that involves geography. But footnote, if you were to use this technique, I would actually recommend using a already kind of pre-baked R package called Google Maps, which allows you to use functions written by another developer to stitch together these type of URL calls, and then, even more conveniently, take this JSON data and prepare it into a data frame, something you're probably, or hopefully by now, fairly used to working with. But if you did have to design your own API call, let's say you identified a really interesting new API, but there was not yet an R package for working with it, well, what you'd have to do is write your own function that stitches together URLs like these and switches out, obviously, the name of the API, the names of the fields, and then your specific credential. Now, as we'll see, getting those credentials usually involves some type of application process, and learning how to identify the part of the API that you want to access can be challenging. It means reading through something called the API documentation, which is just API speak for the instruction manual for how the API works. Just like instruction manuals for everything else, some of them are better than others. Some of them contain detailed information about everything you could possibly want to know, sometimes too much information. Others contain worked examples or vignettes that show you how to do it step by step. Still others offer you what's called a sandbox, which is kind of a virtual environment where you can try out the API without actually writing your own code. We're about to look at one of those in just a minute. So the next thing we have to kind of wrap our heads around is the concept of API credentials. So again, these are your secret codes that you need to define yourself vis-a-vis an API. And the API then uses to determine what type of data you are allowed access to. Now, there are some APIs that don't require credentials. Those are fairly rare these days, but there are some that you might just simply make a call to without a credential and get some data back. But if we look at an example like Facebook, here's a sandbox or a kind of virtual environment for us to play with to use Facebook's so-called Graph API. They just added the term graph. I don't know why. Maybe because, after all, it's a network. But if you follow me here to developers.facebook.com/tools/explorer, you should see an interface that looks something like this. Now, if you don't have a Facebook account, unfortunately, you won't be able to use this tool. The tool works by creating an access token, which is our credential on Facebook. And if you click on the blue button, you'll generate an access token. And you can see it. It's just a long nonsense string of numbers. And then you'll be able to put in different types of search queries within the bar at the top of the screen. So by default, it will start by calling your own Facebook page. But what I'd like you to do to try to get a sense of how credentials work is put someone else's Facebook name in that top bar. I chose Mark Zuckerberg. Zuck is his Facebook name. Now, if you need to find out someone's Facebook name, you could go to Facebook, put that name in the search bar, and then once you see www.facebook.com and then backslash and then a name, that's the Facebook name that you would need in order to try to query it in the API. And what you'll see in playing around with this tool is that you can't get access to information about many people on Facebook, typically only those with whom you are already connected. You can, with this tool, however, see the types of data that one can possibly get via Facebook's API. If you explore things like the fields that are available by clicking on the interface on the left side of this page, or looking at the types of permissions you can request from users. And what that means is the types of things that if you built an app, you could ask users for. Their birthday, their favorite music, whatever you were interested in. So if credentialing is the first thing we have to wrap our heads around with APIs, the second kind of tricky thing is rate limiting. Now, rate limiting simply means that an API has rules about how much data you are allowed to collect within a predetermined amount of time. So here's an example from Twitter. This green part of the graph here describes the actual amount of Twitter data collected, but the pinkish code describes the total number of requests that the person who wrote this hypothetical piece of code wanted to get from Twitter. Now that vertical line, right around 10 minutes, the y-axis here is the number of tweets and the x-axis is time, right around 10 minutes you see that the user just stopped collecting tweets, right? And that's because of rate limiting. For different types of API calls, there are different limits about how many calls you can make within a certain amount of time. For Twitter, some things, like getting a list of tweets about a given subject, get limited at about 18,000 tweets every 15 minutes. If, however, you wanted to collect some social network data from Twitter, that would be rate limited much more stringently. You can't get as much in the same amount of time. So rate limiting is something that we have to learn to code around, to put pauses in our code so as not to trigger rate limiting. If you notice that your code is kind of slowing down, it's possible you're also being throttled. That means the website is kind of telling you that you're really testing the limits of the rate limiting and starting to return the data to you slower and slower, a process many of us call throttling. Now, if you see the types of error messages like OAUTH, that's usually a credentialing problem. But if you see any kind of error message about a rate limit or a rate limit exceeded, you have likely exceeded the amount of data you are allowed to collect from that API within a certain amount of time. So just be mindful of credentialing and rate limits. These are two issues that tend to trip up a lot of people as they try to wrap their heads around APIs and how to use them for practical data collection in computational social science. So next, I'd like to teach you how to get your credentials with Twitter. And then we'll start using an R package to start making calls to collect Twitter data. So the first thing you need to do is navigate to developer.twitter.com. That'll take you to this page here. Now, if you want to follow along with this example, you will need a Twitter account. You certainly don't need to use this Twitter account. You could just think of it as a way of getting your credentials. But it's important that you realize that Twitter, as a large corporation which has certain obligations to its users and legal obligations, needs some way of keeping track of who is accessing their data and when. And so by creating a Twitter account, you're essentially creating a digital signature that allows Twitter to track you. Now, once you've kind of created a Twitter account, if you don't have one, or once you've logged into developer.twitter.com, you can click at the top right of the screen here and see this page, Getting Started. Getting Started will take you to the process of creating your first app. Now, if you're wondering why you're creating an app, why am I creating an app? I don't want to build an app yet, I just want to get some data. Again, this is kind of API speak. Most of the people who work with application programming interfaces are software developers who are building apps to help, say, businesses connect with one another. They're not computational social scientists like you. But for the moment, you have to think of yourself as a software developer. So go ahead and click Create App, which is down here towards the bottom of this screen. And that'll take you to another page called your app dashboard. Now, if this is your first time making an app on Twitter, you won't see any apps. You'll have to click on Create an App at the top right-hand side of your screen. When you do that, you'll be taken to an App-lication page here. See what I did there? And on this page, you'll have to fill in details about your app. Now, you may be tempted to kind of rush through this and just get it over with, but this is essentially the moment where you are making a contract with Twitter about what you are going to do with their data. So from this perspective of Twitter, it's very important. And what you say here could determine whether or not your application is eventually approved. So as you look through the fields here, you'll see you need a name for your app. Give it a simple name. Don't put spaces in it. Use camel case or underscore in order to name the app. That means large letters at the beginning of each word or underscores in between each word. And then make sure to kind of give each text box here a little bit of attention. You'll notice you're asked for a website. Now, typically, if you were an app developer, this would be the website of your app or your business. Now, many of you, or probably most of you, do not have an app or a business. And so you could just put your own personal site or even your university's site. The main reason that's there is that Twitter is looking for a way to return data to a certain location or review information about, for example, an app's privacy policy. So you don't need to worry too much about that, but you do need to pay special attention to two fields. The first is telling Twitter what you're going to use the data for. My advice to you is to be as honest as possible. Tell them exactly what you want to do with the API. A perfectly reasonable start might be something like, I'm taking a class on an introduction to application programming interfaces, as part of the Summer Institutes in Computational Social Science, and I'd like to get credentials in order to test out some code and perhaps whatever else you want to do. Collect data on politics or collect data on COVID-19. And what I would do is be as specific as possible. Twitter is on the lookout here for any kind of people who seem like they might have malicious intent with the data or who may not follow their policies. They're also on the lookout for people who are going to be making bots that might say spread misinformation or sow discord. And so even though this process might frustrate you and you might feel even entitled to this data, remember that Twitter has a lot of responsibilities towards its users. And then what it's really trying to do here is to weed out the bad apples. If you were asked for your phone number when you signed up for your Twitter account, for example, that's a way of Twitter preventing lots of people from generating a lot of fake accounts in order to develop a lot of credentials in order to, say, build a bot army or something like that. Don't build a bot army. One really important thing is in the box that says Callback URL, you need to put this number. This number is the digital signature of your own computer. This means the place where the API is going to return the data. If you owned an app or some other website, you could put in the specific IP address or digital signature of that particular computer. But you want to use your own computer, and this is the universal signature for one's own computer. After you've gone through this process, unfortunately, there's a high amount of variance in how quickly people's applications are approved. Some people's applications get approved in minutes. I've seen others have to wait weeks to get their credentials. Now, the weeks is a real outlier. I'm talking about maybe 3 or 4 people I've taught out of, say, a couple thousand. Now, most people are going to get their credentials within a day or two. Make sure to check your spam filter and make sure that you are diligently replying to any requests for follow-up information from Twitter. Once you have your app, you can open up your developer console again in your app console and navigate to your app. And the first thing you're going to want to do is retrieve your keys or credentials from your app. Each app page has a tab called Keys and Tokens. I've clicked on it here, but I've actually blurred out the names of my actual credentials so that people all over the internet can't use them to, say, sow discord and build bots. But you can find yours here. You can triple click on the box, which will highlight all of the text within that code chunk, and then control copy and control paste it into the R code that I'm about to show you. A very common misstep at this stage is that people either fail to highlight the entire text chunk or they add a space before or at the end of the text chunk. So next thing we're going to want to do is install the wonderful rtweet package developed by Michael Kearney. You can simply install it here. There's also a version on GitHub, which you could install using the DevTools package if you wanted to get the most up-to-date version. There's always a trade-off in installing a GitHub version. Though it might be more up to speed, it might be less stable and less well tested. So if you're kind of risk averse, maybe start out with just this code here, install.packages rtweet. Next, in this code chunk, I'm showing you how to first load the package by writing library rtweet, and then defining your credentials as objects, specifically your API key and your API secret key. The code here has, again, fake credentials. You need to cut and paste yours in here. Next, you use rtweet's create_token function in order to authenticate yourself with the API. Now, when you run this little chunk of code here and define a token, what you're actually going to see is a web browser open on your computer and ask you to authorize the name of your own app. You can say yes, and then when you return to your R console, you will have been authenticated, and congratulations, you can begin requesting data from Twitter's API. So let's make our first API call together. We're going to use the function search_tweets to try to collect 4,000 tweets about coronavirus. And so in this little code chunk here, when you run it, you'll see a little status bar in your console of your RStudio window, and that's telling you how quickly the data are being collected. Typically, you want to limit yourself to 18,000 tweets. That's the point at which one gets rate limited. Usefully, the rtweet package and search_tweets function in particular has an argument that can be added to this code called retry on rate limit, which will essentially build in a pause to the code and continue collecting data. These data, unfortunately, are only going to describe about the last 6 to 9 days of information about any given search term. So you might want to say, go back and study the Arab Spring. It's unfortunate that it's no longer possible to get that data unless you purchase it through Twitter through a service known as its premium API, which is quite a bit of money. So typically the way that we use this search tweets function is either to suddenly collect data about something that's emergent and unfolding, or prospectively every day collect a batch of data. Now when we're running this, we're actually not getting all the data that's on Twitter. We're getting a small micro sample of that data. We're pretty sure it's a random sample, although there's been some evidence that bursty behavior, sudden events, can create non-random samples from the data. So just be on the lookout. If you're trying to track something really large like coronavirus, you may have to write several scripts and try to populate as much data as you can. But in the end, you won't be left with all of the data, quite unfortunately, unless you're looking for a very small or rarely searched term on Twitter. Take note that with the search_tweets function, you're also going to be collecting retweets and original copies of that tweet. So you might see, of these 4,000 tweets, 2,000 of them could be a retweet of a popular tweet. You can turn on or off whether or not you want to collect retweets by using an argument within the search_tweets function. So let's take a look at what the data we just collected looks like. I created an object called COVID-19 tweets, and now I'm simply going to browse the column names. And when I do that, using this code, you'll see that there's all manner of different kinds of variables in this data set. You're going to get a timestamp, what time and date was the tweet made. You're going to get the text of the tweet, the name of the person who made it, the number of followers that person has. And if there's geographic information attached to that tweet, you might get that as well. Now that's typically only available for about 1 in 100 Twitter users who agree to share their location with Twitter. There are other techniques for imputing geographic information, which we'll look at in just a minute, but by and large, you're not going to get much geographic data from most people. Now, if we want to take a look at what you might think is the most important part of these data, the actual content of the tweets themselves, we can use base R's head function just to browse the first 5 rows of that character vector. And here's what it looks like. You're seeing just a fairly random group of tweets about COVID-19 and coronavirus. Note that they're coming in different languages. We can, with search tweets, specify that we only want to look for certain languages or in certain places. But here's a kind of taste of what you might be seeing. Take a minute and try it out. Maybe try out some other search terms and see what you come up with. Get a feel for how this basic function works and what the data look like. Next, you might be interested in kind of looking at the data in a kind of deeper way. So for example, maybe you're out to search for patterns in the use of a certain term over time. You could use something like rtweet's TS_plot, which stands for time series plot, in order to create a graph of the distribution or frequency of tweets over time. So here, we're passing the data set, the object that we created, the data frame, COVID_19_tweets, and we're going to plot just about 10 minutes of data using the tsplot function to look at the frequency of tweets that are mentioning coronavirus. Now, as a pretty random example, why would you want to look at one 10-minute period on one day? You might not, but now imagine that we were studying a revolution and trying to pinpoint the exact point where a certain hashtag was being used. We can play with that filter by specifying different amounts of time within the tsplot function. And if yours is blank, it suggests you probably need to use a different plot. Maybe there's too few tweets to plot, or there's too many to plot within your chosen time increment. So try out a few. Next, we might want to limit ourselves to one location. So if you noticed in our last example, we collected some tweets about Italy. We collected some tweets in different languages. Suppose we only wanted to look at the United States. Well, we could use search tweets again, but this time limit ourselves to tweets about English, and then try to geocode or encode with geographic information tweets associated with the USA. This time we're asking for 3,000. We're asking it not to deliver retweets, and we're asking for recent tweets instead of popular tweets. By default, the Twitter API delivers both recent tweets and popular tweets. So if you want just the most recent ones, you should specify recent. Next, we're using another function in our tweet called lat_long to extract the geocoded information from those tweets. And now we're going to plot it on a map of the world using R's maps package. So if you put in this code, you should see something like this. Now, if you tried a different type of search term and you're not seeing lots of data points, it could simply be that there's not a lot of geocoded information about your particular search term. At the present moment, coronavirus is on the tip of everybody's tongue, and so with 3,000 tweets, we got easily 300-400 geocoded tweets, which you can see here are mostly in North America because we restricted our search to the USA. Now, the rtweet package becomes a lot more powerful when we want to do more than just, say, track an individual term. Some of the deepest, most interesting data is about individual Twitter users themselves. So one workflow is to try to look for all of Twitter and find a term of some significance and track it. Another is to come up with a list of people who you want to extract information from on Twitter, and then collect data about them. Now that second strategy is nice because we can actually get approximately the last 3,300 tweets of any given Twitter user. So unless you're hoping to study someone who tweets, say, once a day or every minute or many times a day, you're going to get a pretty good historical range of a large group of people. So here's, for example, how we would get the last 5 tweets by Donald Trump, but we could again ask for up to 3,200. And here we see what President Trump is tweeting about. Now, suppose we wanted to get a little deeper information about the user, the number of followers, the location defined in the person's bio, maybe the text of the bio as well. Here's how we do that for Barack Obama. We're creating an object called Obama Twitter profile, and then we can from that pull out the description that would say he's, I think, president, husband, and so on. We could get location. I believe he says Chicago, maybe Hawaii, who knows, whatever Obama put on Twitter. And we can get the number of followers. We can also get a count of the number of people that each person follows. We can also get the favorites of individuals using the get_favorites function. Here we're pulling the last 5 tweets that Obama favorited and creating a new data frame called Obama_favorites. Some of the most powerful data that come from Twitter are about social networks. And so I had to get the social network of Duncan Watts, who was one of the first people to recognize that the principle of 6 degrees of separation holds on online spaces. So if you wanted to pull the names of all the people who follow Duncan Watts on Twitter, you could simply use this get_followers function. Now this is actually going to produce a list of Twitter IDs and not what are known as screen names. Screen names are what you might know as the Twitter handle or ID. In this case, Duncan's Twitter handle is Duncan J. Watts. But Duncan also has a numeric identifier. And the reason all Twitter users have a numeric identifier is that one can change their Twitter handle, but they can never change the Twitter ID. So if you want to track people over time, it's better to have their Twitter ID rather than their Twitter handle. So when you pull the names of followers, you'll get those IDs, and then you'll have to take another step. You'll have to look up those users in order to extract their usernames or Twitter handles. A final really handy part of the rtweet package and Twitter's API more broadly is that it allows you to check your rate limits. You may be frustrated if you start working with an API to discover that many of them don't share information about when you're going to get rate limited. Now, the reason for that is pretty simple. If you think about it, if I were a company and told everybody exactly how much data they can get within exactly the same amount of time, everybody would push it to the limit, right? And then the whole system might fall down. Twitter, on the other hand, gives dynamically updated data to any user who asks for it. So we can use this rate limit function in order to see here that I have 75 remaining requests for retweets people made of me, or I can ask for 900 messages from an individual user's timeline or Twitter feed every 10 minutes. And you can see here that I could use this table to build into my code some pauses to look up how many remaining requests I have in order to avoid rate limiting. A more straightforward way to do this would just be to build in pauses using, say, R's sys.sleep function in order to pause at the end of a data collection loop. We can get trending topics by location using get_trends. And one part that's particularly near and dear to my heart, because I've used it in one of my own studies, is the post_tweet function. So if you wanted to, with your current Twitter account, tweet "this lecture is ASICSS-y," you would simply write this piece of code here, post_tweet. We're going to talk a little bit more about using bots for social science research in a future lecture. But I just wanted you to see how powerful APIs are through some simple lines of code. And remember that the developer of the rtweet package has done a lot of work for us in building in all these URL calls, sifting through all of the messy data that comes back, the JSON data, and then integrating it with a lot of core features that we like in R, like dplyr or ggplot. So obviously you don't want to just get data one time. Very often you have a large list of search terms or, say, a large list of users that you want to track. Well, then all of the functions that I just showed you could be replaced or placed within a loop. And that's a typical way that people might collect large amounts of Twitter data. So before I wrap up, I just want to say a few things about other resources that are out there. There are many other R packages for other types of APIs. I've alluded to a few of them. Google Maps, Google Language R is a neat one for natural language processing, which we'll learn about in a future lecture. ROpenSci has a lot of, it's kind of an archive of various R packages that are of particular interest in the open science framework, and many of those have interesting open data API sources. World Bank, OpenGov, R-Times, there's a lot of fun stuff there, so check it out. And remember to always check out GitHub as well. Often some of the more exciting new stuff is only on GitHub. I've also created a crowdsourced list of APIs of interest to computational social scientists. So if you've got these slides open, you can click on this link and you'll be taken to a Google Doc. And if you see some stuff that's not on there that you know about, please go ahead and add it and pay it forward so that everybody can discover new data. So one final kind of neat thing about APIs, as I mentioned at the very beginning of this lecture, is they can be used not just to collect data, but also to analyze your data. So one popular example is the graphics or visualization tool Plotly, which can produce interactive graphics. And that works via an API. But also some of the latest and greatest forms of machine learning use APIs. You might use optical character recognition APIs in order to encode language from, say, handwritten notes or something like that. So just footnote that in the back of your mind, that APIs aren't just about getting data, but also increasingly analyzing your data. So what are the challenges of working with APIs, just to wrap up? Well, the first one, which is pretty unfortunate, is that a lot of the best data remains locked up behind closed doors. So the amount of public data out there is maybe not as much as we'd like. A second main challenge is that every API has its unique standards, unique naming conventions, and unique rules for how it works. So learning how to use an API, again, often means reading closely the API documentation for the API that you want to work with. And there are more fun things to do than that. But that's all I got for you today. Hope that was helpful. Remember, you can always check out the annotated code, which includes all of the links in this lecture, as well as the code chunks themselves if you prefer to copy and paste from there. So suppose you want to go a little bit deeper and probe into those results that you just generated using search_tweets. Suppose, for example, you want to look at the frequency in which those tweets were shared over time. rtweet has a number of interesting visualization tools for you as well, including the ts_plot function, which you're seeing here. Now what we do is we take the output of the search_tweets function and put it into the tsplot function as an argument. Then we specify a certain time increment, and you may have to play with this a little bit. If your search term is very popular, you may need to use seconds. If your search term is very rare, you may need to use days. And if you're not familiar with ggplot, you want to go back and look into those tutorials from RStudio or another source in order to understand the rest of the aesthetics at the bottom of this code. But more or less, this code should produce something that looks a little bit like this. A time series plot that describes the frequency of tweets about coronavirus, in this case over a 1 hour period in one day in May of 2020. Next, you may want to go even deeper and try to look at, say, the geographic distribution of tweets about an issue like coronavirus. And so one thing you might want to do is to try to take advantage of some of the geocoded information within Twitter. Now, about only 1 in every 100 Twitter users shares information about their geographic location with Twitter that you can then pull from the API. That's not a lot, and there's obvious issues of representativeness in those 1 out of 100 people. People who are in vulnerable positions probably aren't going to volunteer their geographic location to Twitter. But nevertheless, let's try it out. Let's do that same search for coronavirus. This time we're specifying only tweets in English. We're going to try to look for tweets that are in the US, and we're going to look for only original tweets and not retweets. You might also notice an argument there, type equals recent. rtweet allows us to search for either recent tweets, the most recent tweets available, or popular tweets, those that are retweeted the most. By default, it will return a mix of the two. So if you want only recent tweets, specify recent like I did here. Next, if we pass that to the maps package in R, which has some kind of unusual syntax here, we can produce a plot that looks something like this and try to get a sense of where people are talking about coronavirus. So thus far, we've been focusing on searching for an individual search term, or maybe you want to track a hashtag, and we're looking at trying to look at a sample of all of Twitter. An arguably more effective way to utilize Twitter's API is to come up with a list of users that you want to track. So maybe you want to track all members of the US Senate and see what they are tweeting about. And so maybe you generate a list of all those senators' Twitter handles, and then with tools like this get_timelines function, you can then pull all of the most recent tweets for that particular individual up to 3,200 tweets. So that, for many individuals, will get you up to a year of data, maybe more. If someone tweets very often, obviously you're going to get less data. But either way, this allows you to go much further back, historically speaking, than the search_tweets function does. So it's really handy to have, and if you build your sample around some kind of known population, it's much easier to collect large amounts of longitudinal data from Twitter. So, for example, here's some tweets from President Trump, the last 5 tweets from President Trump. You can also get general information about a user. So let's say we wanted to look up information about at Barack Obama, which is of course former President Barack Obama's account. Then we could find out, for example, what language he uses to describe himself, where he lists his location as being, the number of followers he has, the number of people he follows, and many other features at the user level. So make sure to check those out. We can also get the favorites of any given user. So with the get_favorites function, we can generate a list here of Barack Obama's 5 most recent favorite tweets, or tweets that he liked. Where Twitter API data really excels is when we consider the ability to generate social network data. So Twitter is, after all, a social network. And I mentioned that one of the real strengths of digital trace data in an earlier lecture is that it's able to capture social relationships. So with Twitter, we can get either the names of people who a user follows or the names of people who follow that user. So for example, suppose we wanted to get Duncan Watts, the popular computational social scientist, followers on Twitter. We could use some code like this to generate that list. And if we wanted to get the names of the people who Duncan Watts followed to, say, generate what social network theorists call a directed network, where we know the direction of social relationships, we could use the get_friends function. Finally, rtweet has some interesting functionality for checking your rate limit. You might be wondering, why can't APIs just tell me how much data I can get within which amount of time? That would be great, then I could avoid being rate limited at all. But if you think about it, if the platforms did that, if APIs did that, then we could all code right up to the edge of where they want us to, and then their systems might be overloaded. And so Twitter has come up with a somewhat unique solution, which is to allow each user to make an API call to check their own rate limits. And so if you run this code, you'll see a table that looks a little bit like this, that tells you how many more requests you can make within what amount of time before the rate limiting process resets. We can also get trends by location. Here we're getting top trends in New York. We can even post tweets. And in a future lecture, I'm going to talk about building bots for social scientific research. Remember to come back to this line of code here to try out your own post API calls. Basically, if you were to post this tweet here, you would be making a really clever message to Twitter, right? And so when we've built bots in past research, we've used this very function. Finally, all of these techniques become much more powerful when we wrap them within loops. This allows us to iterate across large lists of users, collect massive networks. We have to pause, of course, in order to respect rate limiting, but generally speaking, most of these functions are most powerful when they're wrapped within a loop. Finally, there are many other R packages for working with APIs. Some of the popular ones are R Google Maps, R Language R for natural language processing, R OpenSci, which is an archive of lots of other open source data, including R OpenGov, New York Times, the World Bank, and so on. And there's many more that aren't yet available. Make sure to look both on GitHub and on CRAN, the Central R Archive Network, in order to look at the available packages out there for you. In the ASICSS community, we've also crowdsourced this list of APIs of interest to computational social scientists. There's about 40 or 50 on there. Please feel free to add your own or benefit from those that other young computational social scientists have discovered. Finally, I just want you to know that APIs, that we've talked about them mostly as a source of generating or collecting data, increasingly we're seeing APIs being used for analysis itself. So for example, the Throttling library can be used as a tool for making visualizations, and that's actually calling an API. Similarly, many of the top tools for using machine learning now call various APIs. Or if you wanted to do optical character recognition in order to digitize, say, handwritten text into digital text format, you might also use an API. So as you begin to explore APIs, keep in mind they can also be used to do your analysis for you. So hopefully now you're convinced that APIs are worth your time to check out as a computational social scientist. But let me finish by flagging a few of the challenges. The first is that a lot of them are still not publicly available. And with good cause. There's issues of data security, business interests, legal interests, and so on. A second difficult issue is that every API is different. It offers different kinds of data, but also uses different kind of language in order to generate data requests. So part of learning to work with APIs requires learning the specific language for that specific API. Often, the information about how to do that is in the so-called API documentation. And the API documentation can be really long and frustrating and full of jargon, so it can be difficult to work with. Fortunately, there are many R packages which do a lot of the heavy lifting for you, so make sure to check those out.